In the last video, I showed you how I set up my project. This time, we'll get a little bit deeper. We created a player in the last video. We created a level that has a player and an environment. And now this time, I'm going to show you how I set up the environment. But in order to set up the environment, we first need to have some building blocks. And that's why I created this block scene. So in this block scene, I'm going to right-click, add a child, and I'm going to use a static body 2D, and then I'm going to add a child node called collision shape 2D, and I'm going to add one more child of static body, and we're going to do polygon 2D. Now the reason I'm using polygon 2D is because it allows me to build assets in the game without actually having to build assets. So first we'll choose a shape for our collision shape, and we'll make it a new rectangle shape 2D. Let's turn on the snapping and make sure our shape is 32 by 32. You can see that by these lines up here. 16 pixels outside of the center, 16 negative of the center, and so on. Add that up, you get 32. Let's go to our polygon 2D, click that, and now click the snap points of the shape you want to create. And here we have a basic block. It's white. I like grass, so let's change it to green. Alright, we'll turn off the snapping for now. And then this doesn't really look like grass right now, so let's go ahead and add a texture. We'll click the drop down and click new noise texture, and we'll click the noise texture. We'll change it to 32 by 32. We'll turn anti-aliasing on, and then we'll add a new noise type of noise. Now there's a couple things you need to do here to make the noise legit. And first, I'm going to turn the frequency all the way up, but notice how it's kind of blurry. That's not very good, right? So what we need to do is go down to the repeat and click enabled. That will make sure that it repeats all the way around. And then we'll turn filter to nearest, which will make it more pixelated. But you can experiment with different types if you want. You can also change the seed, which will change the way it looks. I'll change it to 22, or just 20, I guess. And there you go. So you have a block of what looks like grass. Remember, no assets used at all. This is a block. Let's go ahead and save our scene. And now let's make this interesting. Let's go back to our environment. Click on our tile map. Go to tile set and click new tile set. There's a special button down here that says tile set. Let's click that. And we'll click plus scenes collection. We need to give the scenes collection a name. We will call it blocks. And then we will drag our block over to the blocks section, basically. Okay, so now let's go ahead and save our scene. We should be able to start drawing our tiles. So let's click on tile map and make sure we have draw selected. And let's see here, why can't I draw yet? Oh, here we go. So I can start drawing. Oh, but something's kind of weird here, right? Why is it kind of offset a little bit? Well, I think that depends on how your tiles are built. And if you look over here to the right, notice the tile size says 16 by 16, but we know that our tiles are 32 by 32. So we actually need to change that. And there we go. That fixes that problem. So let's drag this down. We can also click the line instead of the, the single tile drawing. And we can also click the square, which will give you a filled in rectangle, but we really don't want that right now, so we'll undo that. Let's just use line. And there we go. We have a level already drawn out. Let's click on environment to get out of that tile set mode and go ahead and Control S to save. Now, notice our game has a level. Our level has a player and an environment. The environment is already built with the tile map, and the player is way over here. Let's hide the environment real quick, and then we'll drag the player right out here to the middle. We'll unhide the environment, and we will click play. Now you can see our player has fallen into this level, but we can't control it yet, so let's work on that. Controlling a player is very easy in the game, but remember, whatever your player does, you should attach it to the player. This is where we need to open up the player script, so let's go ahead and click it, and we'll leave this how it is right now. Well, we'll delete it. Alright, let's be adventurous here. So there's two different ways you can use input for a player. You can call a special function called input, which takes in an event, and you can say if event dot is action pressed, and let's just say left for now. So if you press the action left, then you want to move the player. So you can say this is going to get into some Godot stuff here, so let's talk about it for a second. The event is when you press a key that is of the type input. In this case, the left key, which I currently have assigned to the A key on my keyboard. So if I press the A key on my keyboard, what should happen? Well, remember that our player is a rigid body 2D. Kind of like Mario, gravity will affect it. So we need to get a reference to our player, which is not the parent node, but the rigid body 2D. In order to get a reference to a node inside of a scene, you need to put a $ and type in the name of the node. So rigid body 2D in this case. Our nodes have different properties. If you click on rigid body 2D and you go down to transform, you can see that there is a position. And if you hover it, you can see the property is called position, all lowercase. So if I want to change the position, I can use the dot operator to access that. Dot position. Now, since we're going left, we want to say minus equals. And we want to apply a difference in what the previous value was to the new value. It's going to be a vector 2, and we'll say, let's say we have a movement speed. Var speed equals 100. Well, I think actually in my previous examples, 400 was actually a good number here. So we'll say we're going to do speed as the x value, and we'll have to re-give the player's position here as the y value. We don't want the player's y position to change. We only want their well, actually I think we just do 0, because we're going to minus equals this many numbers of the value. I hope that makes sense. We're going to do negative speed because we want a negative x. Let's look at the 2D world real quick. In Godot, the top left corner is 0, 0, and as we move to the right, the numbers go up, and as we move down, the y numbers go up. So you can think of this as like up here on the top left being 0, 0, and down here on the bottom right being 1024 by 768, which is the size of our view. The reason that's important is because we know that if we want to move left, we want to decrease our x value. If we want to move up, we want to decrease our x value. And the opposite to go down and to the right. We want to increase our value, our x value to go to the right, and increase our y value to go down. So because we know that, then we know that we want to decrease our x value to go left. So we're going to do negative speed. So let's test this out real quick. We'll take out that pass and we'll hit play. And nothing's happening. I must have did something wrong. Hold on. If is action press left, then we're going to decrease. Oh, I think I know what's happening, and this is what I wanted to explain to you. An input event does not happen every frame. It only happens when you type in the key. So if I just tap left, keep tapping left, then I'll keep slowly moving left. Maybe. Something weird's happening here. I don't know. But I think what I actually want to do is run this every frame. So we want to do a func underscore process, which happens every frame, and we're going to say if input dot is action pressed, and we'll say left, then rigid body 2D dot position minus equals vector 2 negative speed comma 0. The difference between input and process here is that input only happens when I press the key, but process happens every frame. That means that every single time, 60 times per second, it will move this position, whereas up here it will only do it when I press the button. So let's delete that and press pass. Let's run it again, and this time we'll hold it. Ooh, weird stuff is happening. Every time I press the left key, it kind of disappears. Why is that happening? During my process on the player, if my input is pressed left, then I'm moving the rigid body 2D dot position minus equals vector 2 minus negative speed 0. Let's just tone this down and see what happens. Weird things are happening. We don't know why at the moment. What happens if we change this to, say, physics process? same thing. Now, the reason I'm showing this to you is because a rigid body 2D operates in a different space than a character body 2D. The character body 2D wants you to apply some kind of force to the player rather than adjusting its position. So what we actually need to do is, instead of changing the position dynamically every frame, we actually need to apply impulse. If I can remember how to do it. Let's see. Rigid body 2D dot apply central impulse, which takes in a vector 2. So we'll take in the vector 2 and we'll say negative speed, comma, 0. Not the letter O. And this is the difference between using a character body 2D and a rigid body 2D. Rigid body 2D is affected by forces and gravity. So if we're going to push this player to the left, we need to apply a central impulse rather than just trying to change its position. So let's try that again. And you can see I'm definitely getting some leftward force here. So let's go ahead and do the next step, which is to check our right movement, which is not going to be negative speed, it's just going to be speed. So we have right and left movement. And we went so fast we broke out of the level. Let's turn that speed down to, like, I don't know, 10. Not 410. And we get a more realistic look at what our game is going to do. So I hope that helps. So far we've used 0 assets for our game. We're only using the built-in shapes, and from here you can kind of build out something special, and I'll continue to do that in the next videos. So stick with me and let's see where we can go. Thanks for watching.